Hello, Math 1550 students. There are plenty of resources, of course, on the book website, but maybe this will help your understanding of frequency distributions and histograms. This is the same thing I would do in class, maybe a little bit shorter, but I like to give notes before the students try the homework, and so I'm going to try and do that for you now. So we're talking about two things that are very related, and that's why I'm doing them together. When we talk about frequency, we're asking how often does something occur? That's what I mean by frequency. And distributions are something we're going to be studying throughout statistics. Distributions of data is what we mean when we say that. And a histogram is a type of bar graph that goes along with frequency distributions, and so we'll see how this works. You've seen histograms before, but maybe not known the name. So here's a set of data from your book. It lists some pulse rates of females and males. And actually, those of you that did homework assignment 0, the survey, you saw that that was one of the things I asked for, was a pulse rate in beats per minute. And, you know, this is just a list of numbers of females and males. There's some large ones, 104 beats per minute. Maybe someone was doing some athletic activity. There's some small ones, 56 beats per minute. But when you just look at a big group of numbers like this, it doesn't tell you all that much. And you want to somehow organize the data. And that's what a frequency distribution can help us do. So what we do when we do a frequency distribution is we divide the numbers into what are called classes. And so here there are 1, 2, 3, 4, 5, 6, 7 classes. And the frequency for a particular class, it says, is how many times we saw something in that, we saw a data value in that class. So there was one person that had a pulse rate between 120 and 129. Here's the one we saw, I guess. And notice this is just females, so we want to be very careful that we label. But when you have a frequency distribution, what you can do is you can put it together with what's called a histogram. And a histogram is basically a graphic representation of the frequency distribution of the data in the chart here. And you remember from algebra class, you had an x-axis and a y-axis that are usually input and output. Well, in a histogram, okay, the y-axis will always represent frequency, and the x-axis is going to represent classes. Okay. There are some definitions from this section that I need to go over, and here they are. We need to talk about class limits, class boundaries, class width, and class midpoints. And actually, if we go right to the histogram and frequency distribution we were just looking at, we can do so. So when we say class limits, these are going to be numbers that actually belong to the classes. So the lower class limits, well, you'll find those here. 60, 70, 80, etc. The upper class limits are the largest numbers in the class, 69, 79, etc. But these are not the same as class boundaries. Class boundaries are numbers that separate the two classes. So what you do is there's a couple ways you can do this. One way is you can take a look at the upper class boundary of one class and the lower class boundary of another class and find the midpoint of those two. So halfway between 69 and 70 is 69.5, and halfway between 79 and 80 is 79.5. What the book will tell you to do is to take the lower class limits, 70 and 80, do what I said. Go between 69 and 70, and the midpoint of that would be, of course, 69.5. The idea is this. When we draw a histogram, which matches up with a frequency distribution, we don't want any gaps. And so you may see the first bar goes up to a height of 12 and the second bar goes to a height of 14, and we don't want any gaps. There would be a gap between 69 and 70 along the x-axis. So what we do is we make that mark right there at 69.5. So I hope that helps you understand what class boundaries are as opposed to class limits. Now we want to talk about class width. How wide is the class? You know, in the picture I just drew, how wide are these bars? Well, if you think about what the class limits were, that's different from the class boundaries. The class boundaries were, in our example, 69.5 here and 79.5 here. So the class width for this example would be 10. Sometimes students will look at a particular class, take the second class that they're looking at, and they'll say, oh, it looks like the width is 9, 79 minus 70. That's not what you want to do. You either want to subtract the class boundaries, or what you can do is look, say, at the lower class limit of 2 consecutive classes. So from 70 to 80 or from 80 to 90, that tells me that the class width here is 10. Okay, so that is the class width. Finally, class midpoints, the values in the middle of the classes. So you can add, well, these limits together and then divide by 2. In other words, the class midpoint for this first class here would be 64.5, or the class midpoint here would be 74.5, not 75. See, 75 is closer to 79 than it is to 70. Or, if you're looking at boundaries, it's closer to 79.5 than it is to 69.5. So you really want to add the class limits and divide by 2 in order to find the class midpoints. Yeah, so that should help you understand what class midpoints are. Now, there are other types of histograms that the book is going to discuss, and I need to mention what these are. A relative frequency histogram is different than a histogram. What it's going to do is tell you basically what percent or what fraction of the data is contained in each class, rather than just frequency. Frequency tells you how many are in each class. Relative frequency tells you what fraction of the data is in each class. And the other type of histogram that we're going to talk about is cumulative frequency, and I'll show that by an example. But to give you the idea on relative, you can look at these two tables from your book. Table 2.2 again was the frequency distribution of pulse rates of females that we were talking about before. And there are 40 females altogether if you add up those numbers. And this was what we used to make our histogram. Now, a relative frequency distribution, what we do is we take each one of the frequencies and we divide by 40. So they show you down at the bottom here, they take that first 12, divide by 40, and then change that to a percentage, you get 30%. So this gives you an idea of what the frequency is relative to the rest of the classes. Now, cumulative frequency is different. In a cumulative frequency distribution, what you do is you count everything less than a certain class limit. So notice, from 60 to 69 we had 12. Well, over in the cumulative frequency distribution, what we'll do is we'll say, let's talk about the pulse rates of females that are less than 70, and that would be 12. Next, we're going to talk about the pulse rates that are less than 80. In other words, all those that are contained in the first 2 classes, and if you add, that's why you get 26. Less than 90, we add the first 3 classes. 26 plus 11 is 37. And so these are going to be called cumulative frequencies. And I want to point out there is a type of graph called an ogive that your book discusses later in the section on other types of graphs, where the ogive is basically a graphic representation of a cumulative frequency distribution, and so you may see that in the book as well. Now, when we talk about distributions, the most important distribution we will study in this course is what's called the normal distribution. And I'm not going to give you a real precise definition yet, but what I will say is you've seen this before. It's what we think of when we talk about what's called a bell curve. The bell curve looks something like that. And what we find in statistics is that sometimes there are certain situations where the data will closely resemble what we think of as a bell curve. And that's what's called a normal distribution of data. So here's an example of a histogram where we would look at that and say, you know what? It's pretty close to a normal distribution, a bell curve. So I wanted to mention that because the book will talk about that. Now, about half of you completed the homework assignment 0, the survey, and I want to talk about that a little bit and explain what we can do with that data. The other thing I'm going to do is have you look at the graphing calculator that you need for this course. You want either a TI 83 or 84, whether or not it's silver or not doesn't matter. But the 83 and 84 both have statistical package features that will help you in learning this material. So I'm going to show you how to use that calculator. If you want to take that out, that'd be great. Okay, so here on the right, I just opened up a Microsoft Excel file. I don't know if you've used Microsoft Excel before. It's a program called a spreadsheet, but it's a great way to save different types of data. And it has many features that are useful in terms of statistics. But what I'm going to do is show you a little bit of how to use the graphing calculator. This is something you'll be allowed to use on exams, and it's going to also be helpful in terms of us learning our statistics. So what you want to do is you want to press this Stat button to get started. And when I press Stat, there are some different menus. I can get to them by going right or left or up or down. I want to stay on the left where it says Edit, and I'm going to press Enter. And I can edit, well, different lists. L1 is list 1, L2 is list 2. And what you do is you type the data right in. So the data I'm interested in here are your heights in inches. And here's the heights of, well, 12 students. And so I have 63 inches, 61. And so I can go ahead and just type these on in. And after I get the 12 pieces of data, I'll be able to do something with them. If I also wanted to record how much money you had in your pocket in change, remember we asked the total value of the coins that you had right now, what I would do is move over to the right for list 2, and I'll start typing in things like, well, 95, 189, someone at $1.89 it looks like, 73, 478, our big money holder, 0, we had a few of those, etc. Go ahead and pause the video again while you enter in that data, and then I'll help you through the next step. Okay, so now I've finished entering the data into the two lists, and I'm going to show you what you can do with it. So one thing we can do is we can sketch a histogram using the software that we have. And to do that, you're going to want to hit, well, remember when you use this calculator for algebra, if you have in the past, you might be familiar with the y equals button that you type in functions for graphing. I'm going to hit second y equals. When I hit the second key, it does the yellow thing, stat plot. And what it does is it goes to my 4 or more stat plots that I can have set up. And so I'm going to go to where it says plot 1, and I'm going to hit enter. And you can choose whether plot 1 is on or off. We want it to be on because we're going to do the graphing. And if I move down, I can choose what type of graph I want. Now a histogram is a type of bar graph. So when you move over to the right and move on top of here and press enter, what you'll find is that down here where it didn't used to say frequency, it does now. See, if I'm on a different type of graph, it may not say frequency. But if I go here, it does. And that's a good indication, okay, you're going to do a histogram. XList is going, when you tell the computer which list, L1 or L2, it's using to plot the histogram. So if we want to do our heights and do a histogram representing our heights, we would use L1. So I'm going to go ahead and do that. And when I'm done typing in what I want, I hit second quit. Quit is right above this mode key. So second quit. And that puts me back to the home screen where, you know, this is a regular calculator. You can do things like that. Okay, so now we're going to do a graph. Now if you just type in graph, I'm not sure it will give you that. You'd probably get something more like this. What we want to do is we want to make sure that we get the graph that we had over there. So what I will do is I'm going to hit second. Now let me do this. Let me hit zoom. And if you hit the up arrow, you can go to the choice you want very quickly. The choice you want to find is zoom stat. Now for me, I guess pressing number 9 would also get me there. But what this does is this zooms in on the data that you have plotted in your statistics lists. And so I'm going to press enter and see what happens. And here is a bar graph. Well, it's a histogram actually. And the heights represent the frequencies for different classes. Now if you want to know what those are, you can hit the trace button. And so this tells me that there is a class whose lower class limit is 61, and then the upper class boundary 62.8. So between 61 and 62.8, we had 2 people. And if I look at the data, let's see, here's a 61. 63 wouldn't be included. I guess there's another 61, so 2 people were there. And there's 2 people that are a little taller. And there's only one person between 64.6 and 66.4. And I guess there she is, a 65-inch, so 5'5". 4 people fell here, 2 people fell here, and 1 person fell here. There's not enough data for me to really say whether or not this is a normal distribution. You need more than 12 pieces of data. So we might check again when I get the rest of the homework turned in, or else we'll look at other data sets. But let's go ahead and look at the second piece of data, the amount of money you have in your pocket in coins. Okay, so to do that, I need to go back to stat plots. And I noticed that plot 1 is on and plot 2 is off. So what you want to do is go, well, let's go to plot 1. We can do it here. And the only thing I'll need to change, of course, is which list we're using for our inputs. And so the way to do that, if I go down to X list, I'm going to hit second and the number 2, and you notice above there's a little L2 written. And that's list 2. Okay, so now we can do the same thing. We can hit second quit to go back to the home screen. And now if I press zoom, and if I go to number 9 for me, or zoom, wherever zoom stat is on your calculator, and if I press enter, it's going to give me a very different histogram. Let me trace so I can kind of see what's going on. So this says that the classes are going from 0 to 95.6, that 8 people had, well, money amounts between 0 and 95.6 cents. And then in the 95 cents to 191.2, there were 3. And then nobody was in this range, nobody was in that range, and then somebody, one person, had, well, $4.78 in coins. Now, one thing you should know is that histograms can look different depending on what you pick for things like the class width and therefore the class boundaries, etc. So I'm going to make some changes just to show you that. And the way to do that on this calculator is hit the window key. And this tells me what the minimum x value is and what the maximum x value is. And then it gives me a scale. And the thing I want to change is the scale. What the scale changes is it changes the class width. And let's suppose I just change the class width to 50. I'll press enter. And I'm going to go back and see what happens when I graph. So if I press the graph button, or zoom stat, notice that we get a very different looking picture. If I press trace, it tells me that 5 people had less than 50 cents in their pocket. Actually, 1, 2, 3, 4 zeros, and a 39. Notice that this 50 didn't get included. We're strictly less than 50 on the calculator. And from 50 to 100, we had 3 people. From 100 to 150, we had 2 people. And so this is a nice way of maybe getting a little more information about the data graphically. Notice that the amount of money that you had in coins, this is definitely not going to be a normal distribution. It seems that most people had, well, it was less common to have large amounts of money. There are quite a few people that had 0 actually. And that's because this is, 2 different types of data. Anyways, hopefully that's enough to get you through section 2.2 and 2.3 homework. Please contact me if you have other questions. Good luck.